Alright guys, welcome back. Happy Monday. We are continuing our lesson with dividing whole numbers this week. And we're going to start on page 128 in your instruction book. We're going to start by looking at the example that they give us. So our example says, in art class, 8 students share 104 scraps of felt. Felt is a sort of material. Each student gets the same number of pieces. How many scraps of felt does each student get? Look at how you could show your work using an area model. So the strategy they chose to use is the area model. They're saying 8 times what number gives me 104? How many groups of 8 can I make if I have 104 pieces of felt? So in order to do that, they broke it down and they said, well, how many groups of 10 would fit in that? And they decided that 8 times 10, one group of 10, would give us 80. 80 times 10 equals 80. 8 times 10 equals 80. So they said, well, if each of the 8 students get 10 pieces, that's 80 pieces that we've already used. But we still have 24 pieces of felt remaining. How many more can each student get? In the ones place, they said, well, I know 8 times 3 will give me 24. So if I give every student 3 more pieces, then I'll use all the pieces of felt that there are, and each student ended up getting 13 pieces of felt. A way that you could check this problem to make sure that you are correct is by doing the opposite of dividing 104 by 8. You could multiply 13 times 8 to see if you get 104. So that is a way that you can always check yourself to make sure you've done the math correctly. If I multiply 8 times 3, I get 24. And if I multiply 8 times 10, I get 80. When I add those together, I get 104, which is what we started with. That's the fact family. 104, 8, and 13 is the fact family. So, we have done the example and we're going to try one on our own. A tailor has 641 yards of material to make costumes. Each costume needs 3 yards of material. How many costumes can be made? Will there be any material left over? So in our small math groups, a lot of us have been using the hangman division model. So you can use the area model that they have shown. You can use the traditional model, if that's how you've been doing it. Or you can use the hangman version. So whichever one you like working with and you're comfortable getting the correct answer, that's what I want you to do. All right, we're going to work this one out. We're going to say we have 641 yards of material, and I need 3 yards for each costume. Oh, each costume needs 3 yards, and we need to figure out how many costumes can we make. So right away, I'm going to do kind of the same thing that they did in the area model, but I'm asking myself how many groups of 3 fit into this huge number? If I have, you know how material comes in like bulk and it's all wrapped around a wooden piece into like a circle, or think of you unrolling that material and seeing how many costumes you can make if you use 3 yards for each costume. Let's see, if we roll out 100 yards, if we make 100 costumes and we use 3 yards for each costume, 100 times 3 is 300. So we have used, if we've made 100 costumes, we've used 300 yards of material. So how much material is left? We still have 341 yards left. So I can do that again. I can make 100 more costumes and use 300 more yards of that material. I still have 41 yards left. So now I'm going to think, well, if I make 10 more costumes, I use 30 yards of material. So what do I have left? 11 yards. I know that I can do 3 more because I know 3 times 3 is 9. And that leaves me with 2 yards left over. So this was yards of material. And this was how many costumes we made. Sometimes understanding what the question's asking will help you solve the problem. So, how many costumes can be made? Will there be any material left over? This is very important. How many costumes are made? We have 100, 200, 210, 213 costumes. And our remainder, 2 yards of material left over. And if you need more room, you're welcome to do these on a separate sheet of paper. We're going to move on to number 15 on page 129 in your instruction book. The prize place has 252 toys to be divided equally among 6 piñatas. How many toys will go into each piñata? So we have 252 toys. And we have 6 piñatas. So we're going to figure out, if we have this many toys, how many piñatas can we have? Six toys go into the piñatas. So let's try. Can we make 100 piñatas? If we have 100 piñatas, we would use 600 toys. But we don't have 600 toys. So we can't make 100 piñatas. We have to go less than that. So let's try 50 piñatas. 50 piñatas, if I put 6 toys in each one, I'm doing 50 times 6. 5 times 6 is 30. And put my extra 0 on the end. That's 300 toys. But I don't have 300 toys. So we're going to have to go less than 50. Let's just try 20. 20 times 6 equals 6 times 2 is 12. Add the 0 to the end is 120. So I can do that. How many toys are still left over to go in piñatas? 132. Oh, well, I just did 120 toys by making 20 piñatas, so I'm going to make 20 more piñatas and use 120 toys, and I'll have 12 toys left over. Now, you guys are really good at your math facts by now, so you know that how many more piñatas can you make if you have 12 toys? 2, because if you make 2 piñatas and you put 6 toys in each one, that uses up the 12 toys that we had left. So my solution, how many toys will go into each piñata? 2. How many toys will go into each piñata? We have to figure it out. 20, 42. 42. I read that wrong this whole time. I said that there were 42. I said piñatas, but I read the question wrong. The prize place has that many toys to put into 6 piñatas. Not how many piñatas can we make. How many toys go into each of the 6 piñatas. It's the same numbers, but I read the question wrong. We weren't figuring out how many piñatas we would have. And I didn't even realize it until I was writing out my answer, because I was answering the question that the book was asking. How many toys will go into each piñata? See, everyone makes mistakes. So this was the number of toys they had. And we were trying to figure out how many go into each piñata. Okay, so we only have 6 piñatas, but 42 toys are going into each piñata. So I wanted to make sure that I answered the question correctly. We did all the math right the whole time, but when I went to answer it, it gave me a better understanding of what the question was asking. And we might have had to rework the problem, but luckily all the math was still correct. Number 16. There are 1,275 people trying out for a show. The director needs to put people in 5 waiting rooms. If each room has the same number of people, how many will be in each room? Circle the letter of the correct answer. All right, let's try this again. There are 1,275 people trying out for a show, but they have 5 waiting rooms to put people in. And they don't want to put 2 people in one room and 7 in the other, and then stick all the other 1,000 people in one room. So we're going to put them in equal rooms. So let's see what we can do. If this is our amount of people, this is our room, and this is how many people in each room. Okay, so how many people are going to go into each room? 5. How many groups of 5 will fit into this? I bet I could do 100, because I know that 100 groups of 5 is 500. What if I do 200? 200, I'm going to make a note down here. 200 groups of 5 is equal to 2 times 5 is 10. Add my 2 zeros. 1,000. Woohoo! Yeah, let's do, if we go ahead and put 200 people in each room, we have 1,000 people put away into their room. But we still have 275 people left to put somewhere. So let's start by doing, I bet I can do a 200. How would I get a 200 people? 40 times 5 is 200. So if I do 40 people in each room, that's 200 more that are going to leave and be put away in their own room. Now, since it's fives, you could easily count by fives to get up to 75. Or, I know that 5 times 10 is 50. Oops. So that leaves me with 25 people. And I think 5 times 5 is 25. So we don't have any people left over that are looking for a room. They all have been put in a room. First, we put 200 people in each room, and then we did 240, and then 250, and 255 people are in each room, and there's no people left over. So I'm going to look back through my answers, and I see the letter C is correct. If I want to check myself, I can do 255 times 5 to check myself. So let me do that right down here. 255. I'm breaking that 255 down into expanded form, and I'm multiplying each place value by 5. So 200 times 5 is 1,000. 50 times 5 is 250. 5 times 5 is 25. I'm going to add all my parts of my multiplication up and see if I get what we started with. 1,275. Oh, my phone's going to die. Is it? Okay, good. It's still recording. All right, so we know that we are correct because we got what we started with. So we're correct. We know A1 is not correct. He chose D. And we have to figure out what he was thinking. How did he get that answer? So he thinks that he is putting 1,250 people in each room. But how many people are there total? Does his answer make any sense? Our mathematical term that we've been working with, is it reasonable? That word reasonable means, does it make sense? Could this be the answer? And I'm going to say absolutely no. Does not make sense. 1,270 is not reasonable. If you put 1,200 people in one room, how many people would go in the second room? There's only 5 other people left. There would only be 5 in room 2, or the second room, or however you want to say it. So knowing that 5, there's only 5 people in the second room. What did he do with his 2 numbers? What did A1 do with his 2 numbers? Exactly. I ran out of room. I'm so sorry. I'm going to make a note up here. My work is starting to look like a lot of yours. He subtracted instead of dividing. And when we get back to school, Miss Pasco will work on her organization as well, and we will work on all of that. So today you have the guided practice. This is today. Tomorrow you have practice and problem solving. Wednesday you will have independent practice, and Thursday you will have your quiz. If this is still not making sense to you, I need you to talk to me. We've done math groups. I want to help you. So please let me know if you are still confused and you've tried it and you've done the practice, we're gonna figure it out together.